Okay, chapter 10.6. You're going to learn about different things you can do with chords, tangents, and secants, and we have some special formulas depending on what type of segments you have. So the first one is the segments of chords theorem. Remember, chords have two endpoints on your circle, and they go through the circle. So here we have two chords, and what's special about these is that you can actually take the pieces of the chord. So in this case we have EA, and we're going to multiply that with the other piece of that same chord along that same line, so times EB, and that's actually going to be equal to EC times ED. So if you look at my colored pictures over here, we have our red pieces multiplied together, and that's going to be equal to my two blue pieces multiplied together. So let's try an example of that. Alright, so we're going to find ML and JK. Here we have two chords, and we know that MN is x plus 2, so I'm just going to put a triangle around that. And we know NL is x plus 1. It's along the same chord, so I'm going to take those two things and multiply them together. And we get x plus 2 times x plus 1, and that's going to be equal to, well, if we look at our other chord, we have x times x plus 4. So x times x plus 4. And that's how we set those up. So that's the geometry part of the problem. Now here comes the algebra. So to solve this, you have to FOIL. So first, which is x squared, outer plus x, inner is 2x, and our last terms is plus 2 is equal to, and then we're going to distribute this x. We get x squared plus 4x, and then we're going to get x's on one side and our numbers on the other. I'm going to subtract x squared from each side. Those end up canceling out, and we have our x and our 2x, so we're going to combine like terms to get 3x plus 2 is equal to 4x. And my last step, I'm going to subtract 3x from both sides to where I get x equals 2. Now that we know that x equals 2, we can go back to my problem, and it says ML and JK. So if we look at my whole segment, ML, let me erase some of this. Alright, I'm gonna go ahead and plug in 2 for x. So we know MN is 2 plus 2, which is 4. And we know that NL is 2 plus 1, which is 3. So if I wanted my whole length, I'm going to take 4 plus 3, which is 7. So ML equals 7. Alright, so let's take a look at JK. Here, KN is 2, and then NJ, if we plug in 2 plus 4, which is 6, that means JK is 6 plus 2, which is 8. And those are my two answers. That was a little complicated, so I want to do a little bit easier problem so that way you can see from a different perspective. Here we want to find out what x is. So I know that x times 3, so 3 times x, is going to be equal to 4 times 6. So 3x is equal to 24, and then to get rid of your 3, you divide, get x equals 8. Okay, so that's another quick way to show you how the chord theorem works. Alright, now we're going to move on to a different equation. We're going to have our tangent segment and our secant segment. Alright, so when you have a secant, that means it goes all the way through your line. If you look at PQ, that's the external segment. It's on the outside of my circle, and then I have QR, which is on the inside of my circle, and then we have a tangent segment, which touches my circle at this one point. Okay, so the secant of secants theorem, that means you have two secants. You're going to take your external piece, so your outside, and you're going to multiply it by your whole line. Okay, so that's where EA times EB comes from. And you're going to set that equal to your other external piece, so EC, and you're going to multiply that by the whole line, ED. Okay, so let's try an example. It says find the value of x. Okay, so here we have two secant lines. So what that means is that I'm going to take 9, which is my outside piece, and I'm going to multiply that by my entire line, okay, which is 9 plus 11. So 9 times, and then 9 plus 11 is 20. And I'm going to set that equal to, well, if I look at my other line, I have my outside, which is 10, and I'm going to multiply that by my whole line, and I'm going to make sure to put my plus sign so that way I remember it's not going to be 10x, it's going to be 10 plus x. Very, very, very important that you realize that. Alright, so now I have my equation set up to where I can find x. We have 9 times 20, and that's 180. And then here we're going to distribute our 10 to get 100 plus 10x. Subtract 100 from both sides. We're going to get 80 is equal to 10x on both sides. We get x equals 8. Alright, so that brings us to our next theorem. If we have a tangent line, well, if you think about it, it is the outside piece. However, there's no inside piece to multiply it by, so you're just going to multiply it by itself. Okay, so that's where this squared comes in. And then the secant line, you're going to treat it just the same way as the last example. You're going to take your outside piece and you're going to multiply it by your entire line. So for example, here we have our tangent line, which is RQ, and then we have our secant line, which is RT. So if you take a look here, we have RQ squared is equal to RS, which is this outside piece, times RT, which is this whole line. So if we plug these in, we have our tangent line, which is 16, and we have our outside piece, which is x, and then our whole line is x plus 8. Okay, so we get 16 squared, which is 256, and then when you distribute your x, you get x squared plus 8x. If you get them each to one side, everything to one side, what you can do is factor, but in this case you have to use the quadratic formula, and for those of you who can't remember, it's negative b plus or minus the square root of b squared minus 4ac divided by 2a. A, b, and c. A is the coefficient on your x squared, so in this case it's 1. B is the coefficient on your x value, which is 8. And then c is your constant value, which is negative 256. Okay, so that's where all of these numbers come from. And then, of course, you simplify. Okay, so if you do negative 4 plus 4 square roots of 17, you get about 12.49. And if you do RS is equal to 12. There's also a negative one, so that's why this is the only value it can be. You don't want a negative value. Okay, one other way you can actually plug this into the calculator. Remember, you can go to menu, number 3, which is algebra, and then you can go to number 1, which is the solve. Okay, and it'll be in solve, and you plug in 256 is equal to x squared plus 8x, and then you put your comma, and you have to make sure you define your variable, which is x, and it'll give you your answer, 12.49. Our next example, we're finding the radius of a circle. It says find the radius of the aquarium tank. Okay, so if you take a look at these, we have B, which is a tangent line, and then we also have CD, which is a secant line. So we can use our formula. Our tangent squared is equal to the outside of my secant times the whole secant line. Okay, so that's our formula. Well, if we take a look at our tangent line, it's 20, so that's where the 20 came from. The outside piece, which is EC, is where the 8 came from. And then if we look at our inside piece, that's actually 2R, and then we want plus 8 because we want the entire line. So the entire line is 2R plus 8. Alright, so then you simplify. 20 squared is 400. If we distribute our 8, we get 2R times 8, which is 16R, and then 8 times 8, which is 64. Subtract 64 from both sides to get 336 is equal to 16R. Then you divide by 16 on both sides, and R is 21. So you get the radius to be 21 feet. So let's just try a few examples so that way we can get the hang of it. Alright, so on number 5, we have a tangent line and a secant line. So we know our tangent squared, so x squared, is going to be equal to the outside piece of my secant, so 1, times my whole secant line, which is 3 plus 1, which is 4. So we get x squared is equal to 4. So to get rid of the square, use square root. So x equals plus or minus 2. However, we can't have a negative side length, so it has to be only 2. If we look at number 6, same thing. We have our tangent squared, so 7 squared, is equal to the outside piece, which is 5, and we're going to multiply it by our whole line, which is 5 plus x. Okay? We're going to distribute. You get 7 squared, which is 49, equals 25 plus 5x. Subtract 25 from both sides, which is 24, is equal to 5x. Divide by 5, and you get 4.8. And we're just going to set up the last one for time's sake. This one is going to be your tangent squared, so 12 squared is equal to, and then our outside, which is x, times our whole thing, which is 10 plus x. And then you can work that out. Of course, you would have to distribute. Alright, so last example is the one with that double R thing. I just wanted to make sure we got an example like that. Okay, so we have our tangent line. So we have 3 times itself, so 3 squared is equal to, and then we have our outside of our secant, which is 1, and that's going to be multiplied by our whole line, which is r plus 1. So that's 2r plus 1. Okay, and so now we don't have to distribute the 1 because if you take 1 times 2r, it's just 2r, and then 1 times 1 is 1. Alright, so 3 squared is 9, and then we have is equal to 2r plus 1. We subtract 1 on each side to get 8 equals 2r. We divide by 2, and we get r to be 4. Okay. If you have any questions, make sure you ask your teacher. Thank you for listening to my video.